All right. In the past. In the past being even up to just yesterday. When we came across problems like this, the square root of negative 25, if we were solving an equation and we got x equals the square root of negative 25, we would say no real what? No real solution. That would be our answer, correct? Right? Because we didn't know how to take the square root of a negative. And this is still true. There still is no real solution. There is an imaginary solution, which we're going to learn today, but this is still true. There's still no real solution. All right, so what we're going to learn is how to work with imaginary numbers. So now we have imaginary numbers.
I have a question.
Yes.
Are we ever going to use this? I'm just asking.
Like in real life or what?
Like outside of this class? You're right, you're going to use it on the test, on the final, but I get what you're asking. This is not as commonly used as, say, factoring. And the factoring unit is big. That you're going to do, any math class you take from here on out, you will factor. Imaginary numbers, not as much, but yes, you still will. Like it's not, the imaginary numbers is really specific to, I can't even tell you who works with it in their jobs, but it's not something that you would be doing out there, no.
Yeah, all
right. Okay, we're ready. Here is how imaginary numbers work. The square root of negative 1. We've turned homework in already, so you're going to have to get that in.
Okay.
The square root of negative 1 equals, in the past we'd say not possible. The square root of negative 1 equals I. The square root of negative 1 equals I. Like pi is 3.14, e is 2.17, I is the square root of negative 1. If you were to plug in your calculator the square root of negative 1, it will not give you I. It's going to tell you domain error, or what does it tell you? E? No, it doesn't give you E. No, it doesn't say no solution. It says it's like domain error.
This is just error.
Error. Okay. I do need you guys in your seats, not talking. All right. So with that being said, if you came across something like this, the square root of negative 36, instead of saying not possible, ignore the negative. What's the square root of 36? 6. So the square root of negative 36 is 6i. That's it. It's the only addition. The only new thing. All right. So what if I gave you the square root of, I asked you to simplify the square root of negative 49. Please stop the talking. Is 49 a perfect square?
Yeah.
What's the square root of 49?
7.
So the square root of negative 49 is?
7i.
7i. That's it. You wouldn't. The real number comes before the imaginary. And I'm glad you said that, because I'm going to show you one where it's a little wonky. Square root of negative 8. Is 8 a perfect squared?
No.
Be careful. That's cutting in half. Is 8 a perfect squared?
No.
No. So back first semester we learned how to do this. We would break it up. 8 breaks up into what? 4 and 2, and then 4 is 2 and 2. So I have 2 times 2 times 2. What comes out?
2.
One set of 2's, and what stays in? But what comes out with the 2? 2i, and then root 2. Okay, so do you see how that happens? We used to just call it 2 root 2. Put your phones away. I shouldn't have to tell you that. You should know better. So put your earbuds away, put your phones away, hoods off in class. I shouldn't have to tell you that every day. All right. So in the past, we would call root 8 2 root 2, but the square root of negative 8 is 2i root 2. Now, with that being said, this one, a question was asked, does it matter where you put the I? Technically, the way it should be written is like this, 2 root 2, and then the I tagged at the end. This is the proper way of writing it because the real number comes first, and then the imaginary piece comes second. Now, this is the way we're going to write it in class out of habit. This is just how we do it. And we also, I like it like this because my kid in my last class said, well, is that I inside the radical or not? And especially if you're handwriting things and you can get sloppy and you can't tell, leave the I over here. But if you're taking a standardized test, a state test, the SBAC, and you see it like this, should you know they are the same thing? Yes. All right. Questions on imaginary numbers and how they work or what it is? Okay. Next thing we're going to do is, please stop the tapping. Rewrite using the imaginary number I. Number 1, square root of negative 12. Adam, put those away, please. Put these away, please. Square root of negative 12. In the past, we would say not possible. That's not what we say anymore because we can use imaginaries. So first off, is 12 a perfect squared? No, but we can break it down. Either 6 and 2 or 4 and 3, you choose.
Story.
Yes.
Can we do it the other way with the eye on the outside?
This way?
Yeah.
Yes.
Okay.
Yes, you can. As long as it's easy to read and it's not sloppy and messy and I can't tell what it is. All right. What you 2 and 6? And 6 is 2 and 3? So I have 2, 2, and 3. What's coming out? And what do I take out with it since it's negative? So 2I root, and the 3 stays behind. Now, what did I say earlier? If the proper way is 2 root 3I. But I'm going to write it like this so we don't get confused with our handwritten and sloppiness. All right, number 2, square root of negative 7. Is 7 a perfect squared? Does 7 break down into anything other than 1 and 7? No. Is anything coming out?
Oh, I know what it is.
What is it?
Root 7.
Root 7I is correct. Again, I'm going to write it as I root 7. If you want, you could put it as root 7I. We good? Number 3, before I go on, do you guys see how he got this? He said, oh, I know what it is. It's root 7I. Do you guys understand that? Yes? Okay, number 3, square root of negative 4. I want you doing that one on your own quickly and quietly. Is 4 perfect squared? Sal?
I was gonna say, ask you a question about the I.
Uh-huh.
Do we have to do that on the test?
Do you have to do what on the test?
On the, like, which one?
This way is the most common way you're going to write it and see it in this class. But when you're taking standardized tests, like outside of this class, and you see it like this or like this, no, it's the same thing. Yeah, but this way is the way we're going to typically write it. Cody?
So let's for number 2, if there's numbers that are like that can't be broken down, you just put the I in front of it.
Exactly. So the square root of negative 5, I root 5. Or root 5I. All right, next one, what's the final answer? 2I. Okay, now I've had a few kids ask, what about plus or minus? Anybody wondering that, like why we're not putting plus or minus? We only put plus or minus when we're solving an equation and we square root both sides. Did I square root both sides or was the square root already given to me? It's already given to you. If the square root's given to you with no plus or minus, you don't add the plus or minus. Only when you write it to solve an equation. All right, I'm going to give you the next 3. Just write them down quickly with me and then go back and simplify each one on your own. That's the square root of negative 81, the square root of negative 24, and the square root of negative 11. Go ahead and do those now. when you are done, check with the person sitting next to you. Matt, I need you to stick around after class to get you caught up. All right. Is 81 a perfect squared? So what's the answer for number 4? 9i, because the square root of 81 is 9, yes? So the radical's gone, do you agree? All right. Is 24 perfect squared? So the radical will not be gone. It's going to stick around. What do you guys use? I'm going to put it over here. 2 and 12? Yo, you want to use 4 and 6 instead? It doesn't matter? No. 2 and 2? And 3 and 2? Yes? So how many 2's do I have?
3.
And 1, 3?
Yeah.
All right, so how many pairs of 2's are coming out?
1.
Just one pair, and what do I do with the 2 and 3 that are left? Okay, so what's coming out with the 2 since it's negative? So 2i root 6, or 2 root 6i. Okay, next one. Is 11 a perfect squared? No. Does it break down into anything like 24 is not a perfect squared, but we were able to break it down. Does this break down into any pairs? What's the final answer?
Just 11i.
Root 11i, or I root 11. Because, okay, why does this radical go away? Because 81 is a perfect squared. Why does this radical stay? Because 24 is not. Some stuff came out, some stuff stayed in. Is 11 a perfect squared? Should the radical go away or stay? Stay. And since nothing came out other than the I, it's I root 11. Questions? Are we good? Moving on. Complex numbers. And we're going to continue with complex numbers next week. Well, the rest of this unit. But we will have another lesson on complex numbers next week. Complex numbers. A whole different number plane. You don't write it like you would a real number. You can't graph it like you would a real number. It's similar, but it has a whole different plane. It's not the X and Y axis. It has a real axis and an imaginary axis. It is different. Okay, it looks like this. A plus BI. A plus BI is a complex number. A plus BI is a complex number. Now, you do need to know, I'm going to put here, where A and B are real numbers. Where A and B are real numbers. Got it? Okay, so this A is a real number. I'm going to cover the I. Please stop the talking. B by itself is a real number. But when I put the B with the I, it now becomes an imaginary. So a real piece and an imaginary piece. The real piece always goes first. The imaginary piece always goes second. And this could be a minus. It doesn't have to be a plus. Okay, I'm going to move on. All right. Shh, guys, please stop the talking. Find the sum or difference. Number 1, 7 minus 2i plus negative 3 plus I. Marita, it's here when you're... Okay. 7 minus 2i plus parentheses negative 3 plus I. Now, we had problems like this before, but it was like 7 plus Or 7 minus root 2 and negative 3 plus root 5. Do you guys remember that? Or root 2. And we were like combining like terms. They had radicals instead of imaginaries. We treat them the same way. Because of this addition sign, is this a double distribution problem? It is not. What I do is distribute if there's anything to distribute. Is there anything to distribute?
No.
If there is not, I just drop the parentheses. 7 minus 2i plus negative 3 plus I. Why am I allowed to drop the parentheses? Because there's nothing to distribute. And then you simply combine like terms. What's 7 plus negative 3? 4. And then negative 2i plus 1i. There is a 1 there, don't forget that. Negative I, or negative 1i, depending on how you want to write it. 4 minus I. Decimal. Are we good? Number 2. 1 plus 5i in parentheses minus parentheses 3 minus 2i. All right, is this a double distribution, also known as a FOIL? Is this a FOIL problem? It is not, because there's a what in the middle? A what? A sign, and a subtraction sign. Now, again, can I just drop these, or do I have to distribute first? What do I distribute on this one? Both ways or just to the right? Okay, so the first one stays the same, 1 plus 5i. And then minus 3 plus 2i. Good job. Does everyone see how he got plus 2i? And then you do the same thing as before. Combine your like terms. What did you guys get? Negative 2 plus 7i. Let's say I don't like my first term being negative, so I write it like this. First off, is it the same thing? Negative 2 plus 7i. I just reordered it. So is it the same? Is it okay? It's not okay. I would mark this wrong. I'm going to repeat that. Is it okay? Is not mathematically okay, but I mean, is it like, can we flip-flop things around and it still be the same? Typically we can. Why not in this case? Because what part do we want first? The real part, and which part do we want second? The imaginary piece. Did someone say the fake? Okay, the real piece first, the imaginary piece second. So this would be marked wrong. What goes first? Negative 2, and then plus 7i. A is negative 2, B is 7, negative 2 is the real number, 7i is the imaginary piece. All right, questions before we move on to the multiply piece? What? Just hurry. Okay. Number 1. (5i) times 3i is what we're multiplying. Put your phones away. You guys are paying attention up front. 5i times 3i. You multiply just like you would numbers, like you'd multiply regular numbers. What's 5 times 3?
15.
I'm going to cover this. What's x times x? And don't say 2x. What's x times x is? X squared. What's I times I? I squared. We're going to pause here and clarify some stuff. Okay. Is it okay to have i's like this up here in your final answer? Yeah, expect that tonight. Is it okay to have I squared as your final answer?
No.
It is not. And we're going to clarify what that is. Are you guys ready? This is important. You need to know it not only for this lesson, but for the next few lessons and for the test and for the final. Okay. We know that the square root of negative 1 is what? Square root of negative 1 is I. We just defined that on the previous page. Now, what happens if I were to square both sides? Square and square. We learned, or we've talked about what happens with radicals and with square roots and squares. They undo each other, right? So what would that leave you with on the left-hand side?
-1.
So I squared equals what? -1. That is what you need to know. So I'm going to repeat the question I had earlier. Is it okay to have I in your final answer? Yes. Is it okay to have an I squared in your final answer? It is not. Every time you come across an I squared, you're going to change it to what?
So I equals.
Just right here. I squared equals
-1.
-1. So this next step, you don't have to show all this work, but I am going to go slow just because it's the first one. Does everyone agree that I squared is -1? So I have 15 times -1, which is positive or -15. That there is my final answer. All right. Now kids are like, well, where'd the negative come from? There's no negative. Yes, there is no negative, but I squared is -1, so it's -15. Get it? All right, so let's try a few more easy ones. What was that?
Yeah, it's just unnecessary.
It's, you don't like it? All right, we will eventually learn what I cubed is, I to the 4th power, I to the 5th power. All right, yes. Just make sure you leave your stuff. All right, 7i and 2i. 7i times 2i. Come have a seat. Put that away. Put that away. Okay, guys, those of you that had walked out, this is an important piece that you need to know, so make sure you're paying attention. 7 times 2 is what? 14. I times I is what? Now, you don't have to show this middle step if you don't want to. You can just say, oh, if I squared is -1, 14i squared is what? And that's it, you're done. Any questions on that one?
So kind of just you can just skip the
I-
skip the 14i squared part and just go straight to that like just say that for the number 1 I did the 15 times the -1 pretty much.
This part you don't need. I do need the 15i squared and the -15, but this piece here you can skip.
Okay, wait, what piece?
This one right here.
Just that one, okay.
Yeah. All right. Number 3. -6i times positive 8i. Let's work this out. What's -6 times positive 8? -48. What's I times I? I squared, which is -1. This one I'm going to show the steps only because there's an extra negative in there. Does everybody agree that I squared is -1? So -48 times -1 is what?
48.
I need a volunteer to raise their hand and explain to me, or explain to the class as well as to me, why all of these had an I squared. But these two came out to be negative and this one came out to be positive. A volunteer raised their hand, only 3 people know. Why these two came out to be negative and this one came out to be positive. Yes?
Because the number three, the 48 is already a negative.
Good. So did this one already start off with a negative?
Yes.
And a negative and another negative make the positive. Good job. And these did not have negatives to begin with. That's where the negative came in. All right. Number 4. I'm going to change things a little bit. 2 plus 3i and 4 plus 5i. The quantity of 2 plus 3i times the quantity of 4 plus 5i. Write that down. Okay. Is this a double distribution problem, also known as a FOIL?
Yeah.
Yes, because it's multiplication. We treat it just like we would back in the unit 11 that we did 2 units ago. What's 2 times 4?
8.
8. What's 2 times 5i?
15.
Be careful. 2 times 5 is?
Oh, 10. Sorry.
So 10i. Please stop and listen. Question so far? Okay, what's the next piece I distribute?
The 3i.
3i times 4 is
12i.
12i. And right here, you have to remember, I times I is I squared. So what's 3i times 5i?
15i squared.
15i squared. There's going to be multiple like terms here, so I really need to make sure you guys are paying attention. Are you ready? What is, nope, wrong one. What is 10i plus 12i?
22i.
So 8, no, when you're combining like terms, the i's don't change, right? Plus 22i, but this piece here, you have to be careful. Plus 15i squared becomes what? Negative 15, and I still have another like term. So there is an extra step on this one. Typically, we would stop here. But 15i squared becomes minus 15, and I still have like terms. Do you see those two there? My two real numbers. What's 8 take away 15? Negative 7 plus 22i is the final answer. All right. Digest that one for a little bit. Look at it. Think about it, because that one is a little different.